We are now looking at one of the topics in section 3.4. We're not going to go over everything in 3.4, but one topic. And I mentioned this briefly in a couple of videos ago, but it's determining the absolute maximum and minimum values of a function. Now, this whole idea of finding the maximum and minimum values of a function, for all the problems we're going to work at, there's sort of a new wrinkle. When they give you a problem or a function, they're going to be given upper and lower limits for x. What do I mean by that? Let's just talk about this graphically, and then we would do it mathematically. Say I have a function like this. Now we know, and I talked about, when we talk about maximums, we really have two kinds of maximums or minimums. We have absolute max or min, but then we also have relative max or min. The idea of a relative max or min means when you look all around that point, it's the maximum point. Obviously, for this graph, this is a relative maximum. Normally, I just call it a maximum, but theoretically and legally, you would call this a relative maximum, a relative minimum. When a graph like this, with these arrows, the absolute max and the absolute min would be at the end of the graph, wherever it is, because this keeps going up and this goes down. So notice this maximum here is not a true absolute maximum, because it's not the highest point on the graph. Obviously, all these points over here are larger than this here. That's why this is called a relative maximum, a relative minimum. Now what we're going to do now, problems, they're going to go in here and they're going to sort of impose some limits on the problem. And they're going to say, look at the graph between these two values of x. Maybe we'll call this xl for the low, xh for the high. And now they're going to say, don't look at the whole graph, just look in between these two values of x, this lower and upper limit, and now figure out what the absolute max and min is. So in other words, we've cut off sort of the tails of this graph. We've cut off the part that goes on forever. We're only looking in this part of the graph. Now for this example, if I were to say, where's the absolute maximum? So from here to here, which point is the highest or the largest? Well, you look and it's here. So there's the absolute max. I've got a relative max here, but this point is obviously larger. How about the minimum? I start here, I go up, I come down. This is a relative minimum, and then it goes back up. So really I need to compare how low am I here compared to over here, and obviously this one is lower, so that would be the absolute minimum. So the idea is, within the limits, we're trying to figure out where is the graph the highest and where is the graph the lowest. Now what's interesting, for this example I've drawn, the maximum, the absolute maximum highest point ended up being here on the boundary. We can also call this like a boundary. But for the minimum, turns out it was not the boundary, because in between the limits, in between the boundaries, is actually my lowest absolute point. So this is my absolute min. So that the idea is, in a few minutes, we're going to be given a function as an equation. It's not a graph. If you're given a graph, the absolute max and min's very easy. Within 10 seconds, you can see them right away. However, we're going to be given an equation, and then we're asked to find the absolute max and mins. So what we'll do in a few minutes, we will go into how to mathematically find the absolute max and mins. But just to clarify, let's draw a few more graphs just to make sure you understand what the possibilities are. Because we really don't know. Sometimes the absolute max or mins will be at the limits. Sometimes the absolute max or mins may be in the middle someplace. And it's according to what we have. For instance, let me just throw up a few graphs to see. So let's do a pretty standard kind of a parabola. And let's say these are my boundaries or my limits I'm looking at. Where in here is the absolute maximum? Well, actually, it's here in the middle. That's the absolute max. Where's the absolute minimum? Well, it looks like it's going to either be on this limit or this limit, and maybe this one's just a little bit lower. So there's the absolute minimum. So this is a case where my absolute maximum was in the middle, my minimum was at one of the limits. And you just don't know. How about this one? And say we make our limits here and here. Now here's the thing that I'm going to emphasize when we start mathematically working on these problems. What you really have to do is you always have to look at your upper and lower limit. Those oftentimes will be the absolute max or min. So those are always a possibility. You always have to check those. But besides each of your limits, you also need to check any maxes or mins in between the limits. So really there's two things you need to check when you're looking for absolute maxes and mins. You got to check your limits, your upper and lower limit, and then you have to look between the limits and see if you have any maxes or mins in the middle, and then also check those. Because for instance here, if I were to check my two limits and that's all I checked, I would not actually have the absolute maximum. Because the absolute maximum actually occurs at the maximum in between the limits. So therefore, I have to compare all three of these. That's another way of saying it. You have to compare your upper and lower limit and any maxes or mins in between. That's another way of saying it. So here, I look at my limits. I look in between for any maxes or mins. So I've got 4 points I compare, and I look and I say, which is the absolute highest point? That one's my absolute max. Which is the absolute lowest point? So for this example, actually the limits are the max and the min. For this one, when I compare these 3 points, I decided the absolute highest point was in the middle, right here, and the lowest point was here on this limit. What happened up here? In this case, I would have to compare the limits and any maxes or mins inside. So what's the absolute highest point? Over here on the limit. What did I decide was the lowest point? In this case, it's in the middle. Let me do one more example. How about this one? So hopefully you're visualizing, you're seeing what we're trying to get at. because in a minute, then we're going to try and figure it out mathematically. So this one, let's just go like this, and let's go like this, and let's go like this. And we're going to look, here are our boundaries. I'm going to find the absolute max or min. So you got to compare your limits and any maxes or mins in the middle. So in this case, I'm looking at these 4 points. Now, absolute max of those 4 points, which one's the highest? There's my absolute max. Which one's the lowest? Turns out the absolute max and the absolute min for this one are in the middle both. Here, the absolute max and min were the limits. All right, you don't know. Right? Absolute max or min in the middle, absolute max or min on the limit, sometimes one of each. Absolute min on the limit, absolute max in the middle. So you can have all different combinations. Now once again, when you look at the graphs, it's very easy to see. But it's a little trickier to do it mathematically. And here's what we're going to do. Let me explain to you what we're going to do by looking at these graphs, and then we'll do it mathematically. What I need to do is, I need to go look in between my limits and to see if there are any maxes or mins in between my limits. How do I do that? How do we find maxes and mins? We go take the first derivative and set it equal to 0, and we solve it. When we solve it, those are the critical points. And actually, when I first find critical points, I don't know whether it's a max or a min. And you're going to see in a few minutes, for these problems, I don't really have to figure out right away whether it's a max or a min. All I really want to do is find their critical points. Once I find their critical points, then I'm going to take those critical points, see what's going on there, compare it with my points at the limits, and then I'll be able to get the answer. So let's do a couple of problems, and hopefully you'll see how it makes sense, and it's really not that difficult. So let me just write down, actually it's 2 steps that we're going to follow. And these are the steps to find the absolute maximum minimum of functions when we're given limits. The first step is, in between the limits, find any critical points. So once again, our first step is we've got to see in between the limits, do we have any maxes or mins in here? Of course, the way we do that take the first derivative, set equal to 0, and we solve that. That will tell us our critical points. That's the first step. The second final step, compare. I'm going to say compare the function, because what we're actually looking at is at either the critical points or the points at the limits. We're comparing the value of the function. When I talk about this max and this min, my axis here is the function. So I'm looking at, in terms of the function, what's the largest number for the function? What's the smallest number for the function? Once again, these graphs, the horizontal is your x. The up and down is the function, the value of the function. So what I'm going to do is, this first step, I find any maxes or mins in the middle. And now I'm going to take the maxes or mins in the middle and my limit points, and I'm just going to see where is the function the largest and the smallest. So I have now, when I find these critical points, and then I take my limit points, and then I say, hey, which one's going to be the largest and smallest number? So when I say compare the function at limits and at critical points. And when you compare the value of the function, the largest value of the function is your absolute max, and the smallest value of the function is your absolute min. So let's go ahead, let's do some of these mathematically, and even when I finish mathematically, I can show you the graph and we'll see if it makes sense. So this is in section 3.4. I'm going to do problem number 2. The instructions are find the absolute maximum and absolute minimum, if there are any, of the given function on the specified interval. So they call it an interval. So here is problem 2. They give us a function, f of x equals x squared plus 4x plus 5. And then they specify an interval. And here's how they do it. They say minus 3. So x is greater than or equal to minus 3 and less than or equal to 1. So it's almost like they're basically saying we're looking when x is between minus 3 and 1. I don't know what the function is doing in here, but I want to see what the absolute max and min is. So what I'm going to do is I'm going to figure out if there are any critical points, any maxes or mins inside here. And then I find those, and I'm going to compare those points with my limits, and we'll just see. It's like best man wins. Largest value wins, and the smallest value wins. So to find critical points, you know how to do this. We've been doing this now a lot. To find critical points, you take the first derivative, 2x plus 4. I'll just write it here. And you set it equal to 0. That's how we find critical points, right? We've done this over and over again. So if I were to solve this, whoops, negative 4. Turns out I have one critical point. Now what's interesting is, I don't know whether that, so negative 2 is right here. I don't know whether this is a max or a min. And you know what? For this problem, I don't really care. All I want to do is find out where the critical points are. Because now I'm going to compare. And this is where a lot of students mess up. I'm going to compare the original function. This next step, people keep wanting to use the first derivative. You're done. I'm done with the first derivative. First derivative has done its job. The purpose of the first derivative was to find the critical point. Now I'm going back to the original function, right? This here. I first look at my limits. Minus 3. I'm going to calculate what is the function when x is minus 3. When x is at the lower limit, what's the function? I plug in minus 3 into x of my original function. I don't plug in minus 3 into my derivative. I'm done with the derivative. I'm looking at the original function. I'm trying to find out what's the value of the function at this point. So I have to have minus 3 squared plus 4 times minus 3 plus 5. So this is 9. This is negative 12. That's negative 3. Looks like it's 2. And I'm checking my math, and You know what? I wrote down the wrong problem. This is actually problem 1, which is fine. I'm going to go ahead and do problem 1. Sorry if you were confused. I wrote down problem 1. We'll do problem 2 also. So problem 1, you know what I'm really saying here? Along this limit, my point is minus 3, 2. It's almost like if I sort of tried to display this graphically, I know I'm looking between negative 3 and 1. I know right here at my limit, that's my point. Let's look at the other limit. F of 1, my upper limit. So I plug it into the original function. Right, original function up here. So it's 1 squared plus 4 times 1 plus 5. 1 plus 4 is 5, 10. I'm really saying I have the point 1, 10. Looks like I made my graph too small because 1, 2, 3, 4, 5. It's way up here. I'll be off my page. So these are my limits, but I've got to see what's going on at this critical point. Is this critical point way down here, a minimum, and it's the lowest point? Is it way up here? Is it a maximum? Is it the highest point? So in between here, what's going on? Is my point down here the lowest absolute minimum? Is it in between, so it's not the absolute max or min, or maybe it's way up here and it's absolute max? I don't know where that point is. I need to figure out where that point is. So now I take my critical point, in this case it's just 1, and I say, what's the function when x is negative 2? So once again, I go back to my original function plus 4 times negative 2 plus 5. So that's 4. That's negative 8. So that's negative 4. Looks like it's 1. Hope if I did the math correctly. So that point is negative 2, 1. Negative 2, 1. So it looks like it's a minimum, and it looks like it's the absolute minimum. So now I compare the endpoints. What I'm really comparing are these three numbers, 2, 10, and 1. Which is the largest? That's the max. Which is the smallest? That's the min. So I can say the maximum occurs when x is 1. To be perfectly clear, let's say absolute. And the absolute minimum occurs when x is negative 2. And you know what? I'm going to look that up because I don't want to make a mistake in here. So in the back of the book, the odd numbered answer is, of course, back there. So 3.4, I'm going to find out problem number 1. Always takes a minute to find these in the back of the book. 3.4, problem number 1. Getting closer, closer. Absolute maximum at 110. That's good. And absolute minimum at negative 2, 1. So actually what they asked for, maybe they wanted the point. So we could say actually the absolute maximum at 110, the absolute minimum at MATH201. All right, I will go ahead and also do number 2, just so you can see a couple of these done. Really, the problems are not that hard. So here's the function they give you, x cubed plus 3x squared plus 1. Now our upper and lower limits, now we're going to be, x is going to be between -3, or it's going to greater than or equal to -3 and greater than or equal to 2. So now, first step is, I want to find any critical points between -3 and 2. So I take the first derivative, set it equal to 0. To solve this, I'll factor out a 3x. Two critical points. So you got to check. You always have to make sure their critical points are actually within your limits. 0 is in here, and also -2. Sometimes you have a critical point and it's outside of your limits. If it's outside your limits, then there's no reason to look at it any further, because it's not even a possibility. We're only looking at stuff that happens in between our limits. Both of these are in between the limits. So now I do my compare. First, I look at the limits. And once again, I'm going to plug in my limits into the original function. So f of -3. -3 cubed plus 3 times -3 squared plus 1. Now I did this problem earlier. And I said the function for this, when x is -3, is 1. Let's check the other limit, which is 1. So 1 cubed plus 3 times 1 squared plus 1. Oh, sorry. The limit's 2. This is my previous, I'm not looking. The limit's 2. Sorry. So it's actually 2 cubed plus 3 times 2 squared plus 1. This is 8. Well, I did this math earlier. Turns out when you do the math, you get 21. So those are now the limits. Now I want to look at my critical points. Let's see the function at the critical points. I have 2 critical points. First, let's look at when x is 0. When x is 0, it's pretty easy, right? This is 0, this is 0. It's 1. And then when f is -2, so it's -2 cubed plus 3 times -2 squared plus 1. And once again, if you do the math, you end up with 5. So now we really have 4 values of the function to compare. And all you do, you say, which is the largest number? That's the absolute max, and which is the smallest. So obviously this is the maximum. So it looks like x equals 2, the maximum. Look at the minimum, 1, 1, 5. We have 2. The minimum value of the function is at 2 different points. So basically, like we have a tie. So we have to consider both of them as absolute minimums. So therefore, the absolute max is right here, and the point is 2, 21. The absolute min, we're going to have 2 points. First, minus 3, 1, and 0, 1. Now I actually made a graph of this function. We can see if it looks like what we're saying is true. So here's this graph. Now the limits, minus 3 and 2. Now if we were just to look at this, so we have 4 points we have to check here. Here's a max, here's a min, here's the limit. 4 points to check. What's the max? Pretty easy, right? And if you look, this is at 2. Actually, it's right here. 221. That's what we said. Now the minimum, you know it's got to be, these are the two in the running, and it turns out they both, the function's both 1, and that's why it's like they tie for the minimum. So this is 0, 1, this is minus 3, 1. All right, let's do one more of these. So hopefully, like I said, first of all, you're understanding what we're looking at, and then secondly, you're understanding how we're doing it and finding it not too difficult. I'll do problem number 8, last one. So the function, here they like to use the variable t. F of t is t squared over t minus 1. And we're going to look in between -2 and -1/2. So if you think about it, it's like -2 and -1/2. So that's all we're looking at. So what are we going to do? We're going to see if there's any critical points in between these limits. Then once we find their critical points, we're going to compare their critical points and the limits and see which is the largest and the smallest, right? So let's take the derivative. I'm going to have to use the quotient rule. Low d high minus high d low is just 1 over the low squared. I try and simplify this. Let's multiply out these parentheses. 2t squared minus 2t minus t squared over t minus 1 squared. These are like terms. T squared minus 2t. Now the whole purpose of the first derivative is to allow us to find their critical points. So I'm going to set this thing equal to 0, and once again, since it's a fraction, my solution is going to be when the numerator equals 0. So if I factor out a t, looks like I have 2 critical points, 0 and 2. Now here's a common mistake students will make. They've got their critical points, now they're ready to compare. And that's fine. Let's compare. The limits. We're going from -2 to -1/2. So the original function, I plug in -2. So I get -2 squared. Here's my original function. Over -2 minus 1. 4 over -3. Looks like -4/3. Let's check the other limit. The other limit is -1/2. So into the original function, I plug in -1/2 in for t. So -1/2 squared over -1/2 minus 1. So this is 1/4. -1/2 minus 1 is -3/2. Now if we simplify this complex fraction, basically -2/12, which is -1/6. Oh, did I mess up on the math though? Did I look at my notes? Oh. Actually, I think I'm okay here. I think my notes actually I messed up on. Once again, let's confirm it. I'm looking at negative 1/2. Let's just talk about it. So it should be negative 1/2 squared, and then negative 1/2 minus 1. So negative 1/2 squared is 1/4. Negative 1/2 minus 1 is negative 3/2. Simplify this. Negative 2/12, negative 1/6. Yep. So those are the limits. And then here's where the students make the mistake. Then they're going to go check critical points. And here's what they'll do. They'll just blindly go and they will say, okay, what's f of 0? This is actually wrong. What's wrong? Whenever you find your critical points, you have to check, and I should have said this earlier, you have to check to see whether the critical points are even in between your limits. Look, my limits are, it's not very clear, -2 and -1/2. My critical points are 0 and 2. These critical points are not even inside my limits. Therefore, I don't even check their critical points. It's like they don't qualify. I only look at critical points that are in between the limits that have been set. So therefore, I don't even check their critical points. Now, I didn't know this. I had to go through this. I had to find their critical points. But what I should have done, even before I started comparing, you should always, when you find their critical points, you should stop and check. And on the first problem, I didn't say that, but I should have. When you find your critical points, you stop and check, and you make sure they're inside your limits. If they're inside the limits, then you're going to compare them. If they're outside the limits, then you sort of ignore them, and you're done with them. So here, obviously, this is a smaller number than this, so this is going to be my minimum, and this is going to be my maximum. So we say the absolute minimum is -2, -4/3, and the absolute max would be -1/2, -1/6. Now I actually made a graph of this, and let's see if that makes sense. So here's the graph of that function. But let's draw in our limits. They said look between -2, here's -1, so -1/2 is halfway, and here's -1/2. Now when I went to find their critical points, look at their critical points. We found it to be 0 and 2. Turns out this was a max and this was a min. But look it, they're not even inside the limits. That's why whenever I found those critical points, when I found it to be 0 and 2, and I noticed it wasn't in the limits, I just ignored them, because I'm wanting to know what's going on in this part of the graph. I'm not looking over here. So therefore, the maximum is going to be right here, and as it turns out this is at -1/2, and the minimum is -2. And it looks like my values, I said -2 is -4/3, this is -1, looks about right, and -1/6, those look about right. All right, so that is absolute maxes and mins. Hopefully you will not find it too difficult.